Hi, I'm Brad, and I'm a physicist. There are four fundamental forces: the electromagnetic force, strong nuclear force, weak nuclear force, and gravity. The fundamental particles that these forces act between are called quarks and leptons. Those quarks and leptons make up all of the particles that we know in nature, including the protons and neutrons that make up the various atoms of your body. They are so very small that we have not really measured a size for them yet. They are what we call the fundamental subatomic particles. Gravity is what attracts masses to each other. This force keeps the planets moving around the sun. It's a long-range force, and it's been studied since the time of Newton in the 1600s up through the 20th century, where Einstein developed the general theory of relativity, which describes gravity in a classical sense. The gravitational force between two objects is proportional to the product of the masses of the two objects divided by the square of the distance between the objects, multiplied by a constant called Newton's constant. Well, electromagnetism is really two fairly separate forces, the electric force and the magnetic force, that takes place between charged particles. This force is both attractive and repulsive, unlike gravity, which is only attractive. And there is a unification of these two forces, the electric and magnetic force, into what's called the electromagnetic force. The weak nuclear force describes the radioactive decay of elements. It actually changes one element into another, and it's used in many medical applications such as CAT scans and cancer research. It's also used in anthropology to date with specimens that are literally millions of years old. The strong nuclear force holds together protons and neutrons in atomic nuclei, but more than that, it actually holds together the quarks in various combinations to make up the proton and neutrons. So it is the fundamental force that makes up the basic particles that form the stars, planets, and you and I. The four forces of nature, the fundamental constituents, the quarks and the leptons, are all combined in what we call the standard model of the world. This standard model has been developed over a century by many, many physicists in many, many different countries. It is a remarkably successful theory.
So what have we learned? There are four fundamental forces:
the electromagnetic force, strong nuclear force, the weak nuclear force, and gravity.
Quarks and leptons make up all of the particles in nature. Gravity attracts masses to each other. Gravitational force can be measured mathematically. Electromagnetic force explains electricity, magnetism, light, and forces between charges.
In fact, most of the industrial world is based on the electromagnetic force.
Weak nuclear force describes radioactive decay of elements. Strong nuclear force holds together protons and neutrons as well as quarks. The standard theory unifies theories of subatomic particles.